Now that we've learned a little bit about graphing in the polar coordinate system, let's see if we can apply what we've learned. So I want to graph this point, which is 2 comma pi over 3. So positive 2 means I want to go out to the positive 2 ring on the positive polar axis. And then I want to sweep an angle from that axis out to pi over 3, which would mean this point right here. That is A. So I went out 2 to the second ring, and then I kind of worked my way up to that. So that's A. So notice it was positive and it was counterclockwise. All right, let's do letter B, which is positive again. 1, 2, 3. So I go out to the 3 ring, but it's going to be negative pi over 6, which means that I'm going to be working clockwise. So I'm going to go down negative pi over 6, which puts me right here. That's point B. Now point C is negative 3, right? So make note, right? Negative R. So instead of starting on the positive polar axis, we're actually going to start on the negative polar axis. So 1, 2, 3. So I'm going to go out here to negative 3, and then I'm going to swing counterclockwise. Which is like this, right? So I'm going to go out 1, 2, 3, and I'm going to swing all the way around along that ring. 11 pi over 6, which gets me to here. And there's point C. Amazing, isn't it? You can get to the same points, you can get to all sorts of points on the grid that you know and love, but with a completely different way of thinking about it. Now, there's one other thing that I mentioned in passing, but we want to remind ourselves that there's periodicity in points in these polar coordinate system. So with rectangular coordinates, if I look at B, you go over to the right and down, and that's it. X, Y. But in polar coordinates, that's not true. So in polar coordinates, there's infinitely many ways because of the periodicity of the rotations in polar coordinates. So we could write the point as r comma theta, but then we could just take that theta and add infinitely many rotations or revolutions, depending on which way you want to think about it. And similarly, if you not only can you do it that way, right? So take your positive angle and add infinitely many positive rotations, but then you could take that same angle and make it a negative start position. And then also still add theta plus, see this 2 pi plus 1, or 2n plus 1 pi? That would again be infinitely many rotations, although those ones are odd as opposed to these ones which are even, but still, it's still infinitely many rotations. All right, so let's see how this looks in practice. So I want to take the point A, which I have right here, and I want to get to it in a couple different pairs, ones with R positive and ones with R negative. And I'm going to apply the periodicity property right up above. So I just added in. I want to apply that periodicity property. Otherwise, what's the fun in that? All right, so point A up above, if you remember, was right here. So A was 2 comma pi over 3. So let's think about some ways we can get there. So obviously 2 comma pi over 3, that's boring, right? So let's try keeping with the positive 2, so using this periodicity property. So I'm going to stay with pi over, or the positive 2. Then I want to take pi over 3, which was my angle, theta. I want to add to it a 2 pi. That would be 2, and then this is 6 pi over 3, right? Because 6 over 3 makes 2. So that's 7 pi over 3. Now think about what I'm saying. Instead of just going up, right, which is what we did on the first one. So we went out 2 and up, and that's it, right? But what I'm saying is, hey, go out 2 and go around. Go around a full 2 pi and then add a pi over 3, right? So basically you're saying with this one, go around once and then end up at A, right? That's what we just did. Now, grant you, the picture isn't perfect, but that's because I'm trying to get you to see the revolution. All right, so we did that one. We applied it. We could do it again, of course. We could also do 2 comma pi over 3 plus 4 pi. Oh, 4 pi. I was thinking of my fraction already. All right, so plus 4 pi, right? Because that would be 2 pi times 2. So in other words, adding 2 revolutions. So that would be pi over 3 plus, let's see, this would be 12 over 3. That's 4. So that would be 13 pi over 3. So that's 13 pi over 3. Now think about what that picture would look like. So, you go around once, you go around again, and then you add on a pi over 3, and it gets you to point A. So you're circling twice, right? Because each 2 pi is a revolution. All right, so technically they didn't ask for that part, but there's a couple pairs of coordinates. Now we got one pair of coordinates with positive r, then we have to do it again with negative r. So let's think about that. So if I'm going to go -2, and then if I did this part, so -2, and then take my pi over 3, and I add on an odd number of pi's here, right? So if I put in 1, 2 times 1 plus 1 times pi would be 3 pi. So I could take 1 pi, I could take 3 pi, right? So if you put in 0 here for n, that would be 1 pi, etc. So I could take pi over 3 plus, I'll put in 0 here. So this would be n equals 0. This would be n equals 2. This one is n equals 1, right? And then I could do another n equals 1 down here. I'm going to, but give me 1 second. So this would be plus a pi, which of course is 3 pi over 3. So that would mean that I have pi over 3, oh, sorry, -2, and then 4 pi over 3. -2, and then 4 pi over 3. So what we're doing there is we're starting out at the negative and we're swooping over to get to A, right? So we're going, oops, no, I just went the wrong way. I did it again. I went clockwise instead of counterclockwise. Sorry, my fault. I want to go counterclockwise, so I want to go this way. There we go, because that's a full pi right there, and then an extra pi over 3 right there. All right. What about if I let n equal 1? Not the same as this one, because this one had a positive r. So it could be -2, and then it'll be pi over 3 plus 2 times 1 plus 1 is 2 times 1 is plus 1 is 3. So it'll be plus 3 pi, which is, of course, 9 pi over 3. So that would make -2, 10 pi over 3. Okay, so think about what I'm doing. This will work. So I'm starting at -2, and I'm going around, right? So I'm making a full revolution counterclockwise. So I'm going around, there's 2 pi, and then there we go. And that gets me to A. Now, I grant you, it's not really working like this because you technically go out to -2 in the first place, but in order to show the revolutions, I'm kind of making it look like a spiral rather than really looping around in the circle, which is what it really is doing. Fun, huh? So here's one pair, a pair with positive r's. Here's another pair, and they're all equivalent. All right, so we have a pair of points here, 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 and then these two both have positive r, these two both have negative r. And I could keep going and going forever. There's infinitely many of all of these.